All right, Algebra 2. Here we are in your Chapter 3, Part 1 game plan, which we are going to finish here by Thursday. So this is your video for Wednesday the 20th. We're on page 17. Now, what I want you to do on page 17, number 3 here, is just, there's a mistake. I need to change this. I think I finally did. So the first one has a y-intercept of -1. And you go down 3 over 1. Where's that? -1. Down 3 over 1, down 3 over 1, and so forth. Okay? Dotted line. And you're going to shade below. The second one is a y-intercept of 2, down 5 over 2, down 5 over 2. It's getting further apart. Go up 5 over 2. Anyway, there's no intersection on here. They don't intersect until -6, 17. So all you got to do is graph that first one, shade there, and then, all right, sorry, won't intersect on 10 by 10. That's it. That's a mistake by me. All right, so go to number 4. You have a y-intercept on the first one of -5. Then you go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Solid line, and you shade above there first. You have a y-intercept of 9 on the second one, down 2 over 1, down 2 over 1, down 2 over 1. That is a dotted line. I do check. You're going to shade under. Sorry, you're going to shade under, so the big overlap is right there. Big overlap is right there. All right, so that is page 17, and then we're going to go to page C. So turn back. After page, it goes page 6, then A, B, and C. Again, I am sorry that we got to do this via a graph that's already been really filled in, but it is what it is. So the first one here in black, here's what I did. Put a dot at -7, the y-intercept, go up 3 over 1 a bunch of times, up 3 over 1. That is a solid line, and then shade that line above. Then go to the next one. Y is less than or equal to 8. I did that in red. That is a solid horizontal line. And you're going to shade below. So right now we have some overlapping right in here. And then lastly, I moved this one into slope-intercept form. I moved the x over. So now you have a y-intercept of 1 and a slope of -1. Y-intercept of 1, go down 1 over 1. Down 1 over 1, you intersect with the black line there. Down 1 over 1. Then I'm going to go up 1 to the left, up 1 to the left, until I intersect with the red line here. It's all about where they intersect. That is a dotted line, and it's greater than, so I shade above. And where they all overlap is this triangle, this region of feasible solutions. Now, where do they intersect? The blue and the red intersect here. And if you are confused as to what it is, it looks like it's 2, -1. It's 2, -1. That's the, I call it the second. Vertice doesn't matter. All right, and then here, where do they intersect with? Definitely when y is 8, and that's when the black and the blue. So if y is 8, plug 8 in there for the black and the red, black and the red right there. Okay, so plug 8 in for y there, add the 7 over, anyway, you get 5, it's 5, 8, all right? Then, where do the blue and the red intersect? If you plug 8 in for x, you get -7, 8, that's the third vertex. And that's it, those are the vertices. All right, so have that down for C. Okay, then we're gonna do the same thing here. X is in black there. X is less than or equal to 3. So solid vertical line, you're going to shade to the left. Then you have, let's go out of order here, and let's say y is less than or equal to 9, which was in blue. Solid horizontal line, you're going to shade below. So we've got some intersection over here. And then lastly, y greater than or equal to -3x plus 9. Y-intercept of 9, down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. So you got an intersection there, and you're shading above greater than. So everything comes together in this triangle right there. And where are the vertices? 0, 9, 3, 0, 3, 9. Looking at that overlap. Okay. so 1 is totally done. All right, again, sorry we gotta learn this over video. Is what it is. I took in my final semester at SIU Carbondale, first in teaching, I took a great course. It was Math 482 called Linear Programming. And on a very small scale, involved many variable, many constraints, because in businesses and other things, you want to maximize profit, minimize costs. You want to see what's going to optimize the situation. And this was involved. Different constraints. It might be products, it might be man hours, it might be the cost of something, and something you want to maximize or minimize. You have an objective function. All right, so first off, you need to add this. The fourth one is x less than or equal to 5. If not, you're just going to have a mass. It's just going to go on there forever. It's got to be bounded. All right, it's got to be a region that has bounds. All right, so that's equation 4. Inequality number 4, x is less than or equal to 5. Okay, so let's go in order there. The first constraint is y is less than or equal to 2x. Y-intercept is 0, up 2 over 1, 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 down 2 over 1, down 2 over 1. Okay, now if we're dealing with like products, it's probably all going to be first quadrant. So I just need to make sure I go as far up in the first quadrant as I can. Less than or equal to means I'm going to shade below. I made a mistake here, FYI. Second one, in blue, y is greater than or equal to 6 minus x. There's 6, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, ding, ding, ding. We have an intersection here, down 1 over 1. Solid line, greater than or equal to means I'm shading above. So I've got, just like in this area right now, you can see your shading, I've got some overlap. Then I have y is less than or equal to 6. So you can have 6 or fewer of whatever y is. Solid horizontal line, and I'm shading below. So something in here is now taking shape, right? This is, what is this? This is less than or equal to. So something in here is taking shape. Yeah, this was a mistake. That is not a part of our final answer. Currently, it's like this. See, that's why I needed x to be less than or equal to 5, because this would go on forever. So if x is less than or equal to 5, there's a vertical line right there. It's solid, and you're going to shade to the left, and everything comes together right in there. That is the region, my 4-sided figure. First vertex, is that 2, 4? 3, 6? Wait, where did I say 2, 4? I made a mistake. That's 2, 4. That is 3, 6. That's 5, 6. That's 5, 1. All right, that's all of them. So that is where, in this entire region, you can tell the boss, hey, anything in here works. That's true, but you want to maximize or minimize something. So what you do is you take that 2, 4. That's your x. That's your y. You plug 2 in for x, 2 in for y. So f of x, y. This is f of 2, 4. You plug 2 in for x and 4 in for y, and you see what you get. You get 20. Then I plug 3 in for x, 6 in for y, and I get 30. Then I plug 5 in for x and 6 in for y, and I get 38. And then I get 5 in for x, 1 in for y, and this happens a lot. Like, you're trying to, in a business, manufacturing especially, you're trying to maximize stuff, minimize stuff. You need to know how much of each can you do. So if you wanted to minimize something, then you would use 2 of x and 4 of y. And if you wanted to maximize something, you would use 5 of x and 5 of y. And was a really important class, very useful, very applicable. And on a minor level, that's how the question's finished. All right, so nice work. All right, try this one. X is between -3 and 4, so solid vertical line at -3, solid vertical line at 4, and x is anything in between. And then in red, y is between -5 and 2, solid horizontal line at -5, solid horizontal line at 2, and y is anything in between. You have a 7 by 7 square where they overlap. All right, that should be it with that type of graphing. And on your test, your linear inequalities are going to be on the easy side, so you're going to be good in shape. Okay, that was page 7. That was page 7, by the way. And that's it. So here's what I want to do. I've got just 4 of these, because they are, and we're going to finish the, I think we have an ACT page that we will finish in tomorrow's video. So I just got 4 of these, And we will practice more 3x3s. You know, if you're so struggling on 2x2s, practicing the 3x3s really makes the 2x2s easier. We will definitely practice these again when I'm back. You're not going to take the test, you know, immediately when I'm back. But I do, we got to make progress. I do got to show you how these are. So how in the world do you solve a 3x3? Well, you guys all know, I have page 8 right here. You guys know how to solve a 2x2. You know how to solve this. Just double the top equation, then you have elimination. All right, so if I can get back to a 2x2 situation, I'm in good shape. So I just got to find a way from here to get back to a 2x2 situation. So I want to look, and I want to see, is there a certain variable that's just begging to be eliminated? I've got to eliminate the same variable in 2 different equations. Then I have a 2x2, and the domino effect will start. We'll look at the y's. The y's are either positive 3 or negative 3. They are begging to be eliminated. So that's why I say bye-bye y. Now, Honors Algebra 2 had practiced this a little bit more by this page. So what I'm going to do is I'm going to rewrite equation 1. And I'm going to rewrite equation 2. I'm going to put them together. Why am I going to put equation 1 and 2 together? Because if I add the 2 equations together, my y's will eliminate because my y's are opposites. Negative 3 plus positive 3, the y's will eliminate. All right? So if I add equation 1 and equation 2 together, x plus 2x is 3x. The y's obviously cancel. 3z plus a negative z is 2z. And a negative 4 plus 15 is 11. Now, this is a brand new equation. This is a brand new equation. So, I'll call it 3x plus 2z equals 11. That is equation 4, and that equation has no y's. So my goal is to get another equation like that with no y's. Now, I put 1 and 2 together, so I have to utilize equation 3 next. So what would equation 3 go with? Negative 3y. It's the exact opposite y in terms of y's as equation 2. So if I put a 2 and 3 together and add them together, y's will go bye-bye again. So again, as we're learning this, I want to rewrite this. That's a z. That's equation 2. This is equation 3. Again, I'm adding them together because I have opposite y's. 2x plus 4x is 6x. The y's will cancel. Negative z plus another negative z, they don't cancel. I'm down 2 in debt, so minus 2z equals 15 plus 19, 34. That is equation 5. Now, I'm going to put equation 4 and 5 together. I'm going to put them right next to each other. This is fantastic. Why? Because if I put equation 4 and 5 together, look at the z's. This looks like page 8. The z's are exact opposites. So I can just add both equations together. 9x by z equals 45, and I get x is 5. I got my first answer. I know that x is 5. So what am I going to do? I'm going to use equation 4. I have to go back to either 4 or 5 because that one just has x's and z's. Go back to equation 4. I know what x is, so I plug 5 in for x. And I solve for z. I have x. I have z. I need to figure out what y is, so I need to go back to one of the 3 original equations, and I like equation 2 best because I have a positive y. Equation 2 was 2x plus 3y minus z is 15. 2 times 5, x is 5, plus 3y, minus z. Z is a negative 2, so plus 2 is equal to 15. Y is 1. And I write this as an ordered triple. What is an ordered triple? It's just something that's, it's something that's 3-dimensional. So here, 2D, raise it up, boom, 3D. All right, so look at put your hand in front of your face. Your foot, if it's on the ground, 2-dimensional. You got an X and a Y, raise it up, now we're in 3D. Okay, so 5, -1, -2. Awesome. So let's try number 2. I'm going to try 2, though, why does 2 say Thursday? We don't. Because this one is, well, your video's long enough. We'll just save this one for Thursday, so I lied. We're going to do this one on Thursday, tomorrow, and we're just going to finish up then with this page. And this page is 13. Go to 13. I know we're going all around here. Go to page 13. We've got two pretty easy ones. 4 couldn't be easier. Okay, so on page 13. Your turn. Well, we're going to do this together. What is begging to be eliminated? Look at this, the z's. Positive z, negative z, negative z. They're the same or opposites. Awesome. So I was going to say bye-bye z. And what am I going to do? I'm going to first put, 1 and 3 together. Here's equation 1. Here's equation 3. And the z's are opposite. So holy cow. If I put 1 and 3 together, not only do the z's cancel, but the y's cancel. 6x is 18, x is 3. My equation 4 has been solved. Excellent. So what I'm going to do is I'm going to put 1 and 2 together. Equation 1 and 2 together because the z's are opposite, so I can add them together again. Add them up. Bye-bye z. That gives me 15. That's my, probably call it. I did this one first in Honors Algebra 2 video, so it doesn't matter. Call it equation 4. But I know what x is from what I did first. So x is 3. I plug 3 in for x, and I get 3 for y. Look at that. So I go back to original equation 1 because I have a positive z. 2x minus y plus c is 4. I get z to be 1. 3, 3, 1. Awesome. So the final one here, this video will be long enough. And I'm up at 20% now, battery-wise. Hopefully an easier one. Yes, very easy. That's equation 3. You know what z is, so plug it in there. Y plus 4 is 0. Y is a negative 4. Then go back to equation 1. X plus 2y plus 3z is 6. And the 6's cancel. You get x to be 8. There's your answer. So again, make sure you have your test review on you. We're going to start the test review and probably do 2 days of that, Monday and Tuesday. I will be definitely out on Wednesday. It's still up in the air on Thursday and Friday of next week. So you'll start the next game plan. I will email that to you so you have plenty of time to either print it out at home or print it out at school. You can print to the IMC and we'll go from there. All right, so this is your video. We're almost done with the game plan. We're going to finish the game plan in Thursday's notes video. This is Yak Math Videos signing out.